Well, hello, welcome back. So we started last time into a unit of study called motion, and I'm introducing you to some new terminology probably. Last time it was displacement. I'm guessing that was a new word for you, and we compared it with a more familiar term called distance. But we're going to do something similar. In fact, today's descriptions depend on your understanding the difference between distance and displacement. If you need to go back and review that video should still be available. So here's what we're going to do today. We're going to distinguish between average speed. I think the word speed is probably pretty familiar to you, versus average velocity. Now, I'm sure velocity is a term that you've heard before, but I'll bet you don't know the sciencey difference between speed and velocity. A lot of times they're just used interchangeably, okay? So I'm going to do what I did last time. I'm going to draw a little diagram that helps us describe the difference between the two. Then I'll give you some definitions and descriptions and apply it to that example. So imagine we're doing a little science experiment and we put a little critter, a little mouse or a rabbit or something like that in a maze, and we let them go and they start moving around, okay? So I'm going to draw the path that they take. So let's say this is our start right here. And let's say they start out going 10 meters rightward, like this. Last time I used units of blocks because we were talking about moving around downtown. Now I'm using meters. This might be something you could do in a room. 10 meters. I don't know, maybe that's the length of my classroom in here. And then if they turn and go 5 meters down this way, and then they turn again and go 3 meters to the left, and maybe the maze takes them up, let's say 2 meters now. And then one last turn, and they end up right here. So that's where they end. So they've gone another 7 meters. Okay? So again, that's a rather long, involved path in order to just end up directly below where you started. Okay, so now with that in mind, let's talk about the difference between average speed and average velocity. I'll have you use some abbreviations. AVE is a good abbreviation for average. Sorry, that should be a little period there. We don't use the abbreviation S for speed. We always write out the word, and that's because the letter S looks too much like a 5 and it can get kind of confusing. All right? So to find the average speed, we take the distance and divide it by the time it's taken to go that distance. So you have to know how long it took to do that. Okay? But the average velocity now we can use a V for velocity, and we often do. You're not going to get V mixed up with a number. The average velocity is the displacement divided by the time it's taken. And something I want to emphasize here, including direction. Okay, so let's get some time information because we're going to need that in order to calculate either one of these. So let's say this takes, we're going to keep it real simple, 100 seconds. That's almost 2 minutes. Maybe this critter's a little slow. And let's also just keep in mind that we're looking at north, east, south, and west on this figure. Sometimes we put a little, we call those the cardinal directions, like a compass heading. That helps us know, kind of, are we talking about left, right, up, down? Or are we talking about east, west, north, south? So maybe we're just moving along on the floor, on a tabletop during the experiment, okay? So here's how you would show your work on something like this. Remember, anytime in science or math class you're asked to do a calculation that involves a formula, you always want to show 3 steps, at least 3 steps. In my class, always show 3 steps. One of them is already shown for you, and that's the letters or the words that are part of the formula. So I've got those written here for average speed. We'll do that one first, and then we'll do the velocity, okay? So the second step, you remember this, is to substitute in the values from your particular problem into the general formula, okay? So we would write average speed equals, I always like to rewrite that part, and then we're going to replace these two with the numbers that come from our situation. So we need to know the distance. Now remember what this is. We learned this in the last part. The distance is the total accumulated length of the path that we covered, okay, or in this case, the little critter. So we have to add up all the steps. So that's 10 meters, plus another 5, which is 15, plus another 3, which is 18, 2 more makes 20, and then 7 this way makes 27 total meters. Okay, so that's our distance. So we put that in place of where distance is. Always put the units with the number. And then how long did it take? Well, it took 100 seconds. It's important that you put the units in because the units become part of the answer just the way they're written when you write the second step. You see how it's m over s. We say meters per second, not meters over seconds. So we could grab a calculator, or maybe you can do this one in your head since it's just dividing by 100. But 27 divided by 100 is 0.27. Please don't use fractions, but instead write 0.27 and then the units of meters per second. That is the average speed of the little critter moving through that maze. Now, how is that different than the average velocity? Notice, in the course of this path, the critter ended up moving just as much west as he started out moving east. And so he ends up directly south. And how far south? Well, he had moved 5 meters south here, but then backtracked north 2 meters here. So that means the total displacement is 3 meters south, okay? So again, I can sort of trace a little path here. I don't want to write it too darkly, but 3 meters south is the displacement. And so we write in the second step, average velocity, and then abbreviate, displacement. Now we don't write the word south. We'll write that at the end. We've still taken 100 meters to do that, right? Oh, sorry, 100 seconds. So now we divide 3 by 100. That's known as 300ths, or 0.03. I like you to write 0.03. Sometimes people miss the little dot when you write a decimal. When you write 0 dot, it's pretty obvious that you mean for there to be a dot there. The units are still the same, meters per second. And now we include the direction. So we can write the word south. Okay? So very, very small average velocity, 300ths compared to 2700ths or 0.27 for our average speed. Okay? When you do some backtracking, it always ends up lowering your average velocity, but doesn't necessarily affect your average speed. Okay? So there's a good example between the difference between speed and velocity. It really comes down at its heart to the difference between distance and displacement. So make sure you can master that part. If you need help with that, get a little help with that. Again, the previous video that we did might clarify that for you. Okay? All right. So I think that's going to do it here. You get a little chance to practice as usual. Thanks for watching.